In this video, we're going to demonstrate exception handling in C#. We're starting off with a basic calculator application, which allows us to enter two numbers and then click on the button to calculate the sum. So just to demonstrate this, I'll just run it just now to show you how it behaves. So in the first text box, we put in a number, the second text box, we put in another number, click on the button, and as you can see, we get the result displayed on the screen. Now that all works absolutely fine. However, one of the biggest risks in programming is external user data. We can't stop users from entering values that are available using their keyboard. What this means then is that, for instance, in this application, we could, although we've asked them to enter a number, we could end up in the situation where the user could enter a letter or a special character, or in fact just leave it completely blank. In this case, if we try to get our application to add together these two values, it doesn't make sense. So when we click on the button, this is what happens. We end up with what we call an exception. An exception is just a fancy name for an error. In this case, it's a runtime error. So the program runs, and during its execution, a problem occurs which causes the program to crash. Now when it crashes, it does pop up with a message. The majority of the time, to be honest, the messages are quite cryptic, and of course this is not a good experience for the user. So our aim is to write more robust applications that protect the user from experiencing this sort of behaviour. So in order to do that, we've introduced the use of the try-catch statement. So we are now going to update our code, and we're going to start off with protecting it. So any areas of code we think could cause an error, we wrap them up in the usual way. So to gather things together in a block, we wrap them in curly brackets and we protect that block of code. So let's just do that just now. So what code are we actually going to wrap up and protect? Well, my advice is, when you're looking for code that you think could be at risk, that you want to protect, the first place to look is any code that handles external user data. So for instance, in this block of code here, you can see we're grabbing user data out of a text box, and same with this instruction here. We're then using that data to perform the sum, and then we're putting the result back onto the window. All of these instructions are involved with using the user data, therefore they're at risk. So to protect them, the first step is we wrap them in a set of curly brackets. So we have our opening curly bracket and we have our closing curly bracket. Now at the top of this block, we need to explain to the compiler why we've wrapped up this block of code. So we're going to put in a special keyword called try. So try basically means as it suggests. It will try and execute the instructions that are within the following block. However, it's aware that there might be a problem. So it says go ahead and try and run these instructions, but there may be an issue. The second part of this is we then, instead of letting the program crash, we catch the problem using a catch statement. So the catch statement basically says, try this, if anything goes wrong, catch the error. So inside these brackets, what we can do, optionally, is we can actually catch the error and give it a name. So this is basically saying catch any exceptions, so any exceptions at all, no matter what type of error it is, and when you catch it, put a label on it. What this will allow us to do in future is we'll be then able to look at that particular error using the label and find out a bit more information about it. Now, once you've written your catch, you then need to provide a set of instructions that you want to execute instead of the program crashing. So again, we have our block, and inside here we put in the instructions that we would like to run in the situation where there is an error. Eventually we'd like to get to the stage where we could possibly attempt to write instructions in here that try to fix the error. But for now, all we're going to do is we're going to try and handle the error gracefully and give the user a better experience. So if there is an issue because they've entered invalid data, let's simply, instead of having the program crash, let's simply pop up a message explaining to them that the data they've entered is invalid. So we're going to use a message box, as we're all familiar with, and in here we will put in a message, so something that would explain what the problem is. So we can just put values entered must be numeric, because if they're not, then the program will crash. So that's far nicer than the program causing an error. Another thing we could do is we could actually empty the text boxes so that they're empty again and ready for the user to make another attempt at using the application. So that'd be quite a nice usability feature to add. So let's take our text boxes that have potentially got the invalid data in them, and let's update them. So we've got a couple of options here. We can use the clear method, which will basically just clear out whatever values in the text box, or a more simpler way of doing it is we could also update the text in the text box just to be an empty string. So both of these do the same thing. It's entirely up to you which one you prefer. So let's run this again, and this time let's see what happens if we put in the same data. So here's our calculator. So again, let's put in the letter A and let's put in a number. And before, when we did this, it caused an error. This time it doesn't cause an error. It pops up the message, so the error will still happen in the background. Instead of it crashing though, it catches the error and it runs through these instructions. So right now it's doing the first one. It's popping up the message box saying that values must be numeric. And you can see behind the scenes the text boxes have still got the original values in them. Once I click on OK, it should go ahead and clear both the text boxes. There we go. So now the user has got the opportunity to continue using the application. So there are no crashes, it's a much better experience, and they continue to use it in a proper way. If you did want to look in a bit more detail at the error, again, this isn't something we're going to focus on in this course, but just for information, as I mentioned earlier, because we've caught the error and we've put a label on it, we could actually find out a bit more about it. So as well in the message box, as well as in the message box giving the user a sensible explanation, we could also display what the actual error text is if we felt that was of value. So I'm going to display the message to the user, and I'm also going to display what the actual message is in the error. So to find out the message in the error, I need to use EX, which is a label we've stuck on the error. So that allows me to access the error details, and then you can see all the things that I can ask the error. And one of the things right at the top is I can ask the error, what was your actual message? So that's pretty useful. To make it a wee bit more user friendly, at the end of this statement, I'm going to put in \n to take a new line so that the user friendly explanation is on the top line and then the actual error message is on the bottom. So let's run this again and just see what that gives us. So again, we want to put in invalid data so that it catches error and comes into this block. So let's go back to putting in a letter. So you can see here it says values entered must be numeric, so that was our message, and then it's actually displayed the message that is generated by the actual compiler. So its message is input string was not in a correct format, which isn't too cryptic, but ours is more descriptive because it specifies that the values have to be numeric. Okay, so that's a brief overview of using the try-catch. It's an excellent way of making your program more robust, and really it's the experience you want to give the user, is to have an application that doesn't crash. So the advice is, anytime you are processing external user data, protect the instructions that are involved with the user data using the try block, and then of course associated with that you've got your catch block to define what should happen if an error occurs while trying to execute those instructions.